All right, well, welcome. I want to talk to you in this algebra video about number sets. Now, um, some of you might be rather intimidated by some of the number sets to which we refer in Algebra 1 and 2 even. But I want to try to break it down into something a little more real and manageable. So, the very first set that I want to talk about, and I want to really just walk you through your schooling. Okay, so what I want to do is I want to start with the smallest number set with which we typically deal, and that will be this small little set, and that would be when you're just a real bitty little boy or girl, and you have just started walking around the house, and you might be counting things like your parents say, hey, go ahead and count how many bottles you see there, or whatever. So, the very first set of numbers that we encounter is the counting numbers. Now, as you can imagine, the counting numbers are 1, 2, oops, sorry about that, and 3, and they go on forever, right? It is an infinite set of numbers, 1, 2, 3, 4, 5, whatever. Now, that's when you're very, very young, and you're not even in school yet, right? Okay, so next, let's say you're, maybe headed off to kindergarten or first grade. So what happens at that point is that your teacher introduces to you. So you're going in, you're sitting there, and you're actually in school now. So we've got all these students, and they're raising their hands in class. And so when you're in class, trying to just make it real for you. When you're in class, right, and the teacher is up here instructing on the board or whatever on the Prometheum or whatever, you actually find out that there's something called a zero. Okay. But that doesn't take away from the counting numbers. It just means that we add a zero. So we have 0, 1, 2, 3, and then it continues just like the counting numbers did. But the name of this set is the whole numbers. It's called the set of whole numbers. Okay. Now you could think about that as this zero kind of looks like the letter O, right? An O. All right. So anyway, let's go ahead and move on. So we've got the counting numbers, and then we've got the whole numbers. Now, is every counting number a whole number? Yes, it is, right? It is, of course. Is every whole number a counting number? No. Every whole number, that would include this one, right? And it's not in the counting numbers. So be careful about those types of questions. All right. Then you're getting older and older. You're getting into, you're just getting into third grade, fourth grade, whatever. You're just thinking you're all that. And you're growing up, and you're doing more and more things in school. But what your teacher tells you is, you know what? We don't just have whole numbers, we actually have negative numbers. So the counting numbers and the whole numbers actually fit into a set of numbers. And here's what your teacher does. Probably at this stage right here, your teacher shows you a number line. And here's the 0, the 1, the 2, the 3, and that's right. That's we already know about all these numbers. 5, and then I would make this thing solid, and that would be, oops, I would try to make it solid. And these would be, right, colored in to indicate the whole numbers. But, oops, but what your teacher would tell you is, you know what? There's another side of the number line, and the other side of the number line is over here, and these are negative numbers, right? And so this reality makes you realize, hey, this numbers that we work with, there's a whole lot more than we knew. initially in like first and second grade. So now you're in third or fourth, maybe fifth grade, and you're finding out about negative numbers. Okay? Well, negative numbers are actually just the opposite, right? The opposite side of the number line of whole numbers. Now, we don't have a negative or positive zero, so we don't call that negative or positive. But we do have the opposite of whole numbers is the negatives. So what we call that is we call those integers. Now, what is an integer? The official definition for an integer is whole numbers and their opposites. That's actually what an integer is, whole numbers and their opposites. So we've got negative, well, I'm just trying not to delete this, -3, -2, and now this goes on forever that way, -1, 0, 1, 2, 3, etc. Okay, so integers. Think about this. This integer starts with the letter I. If you take a number line and turn it on its side, right? Turn this number line up and stand it up, right? And take off the arrows, right? Then you can think about that being, right, the beginning of the set of numbers, the integers, okay? So there's that. That's just maybe a silly way to remember it, but silly sometimes is really helpful. Okay. So we've got counting before you even go to school. We've got whole numbers when you get to school and you find out there's such thing as 0. Then we have integers when you're maybe in 4th and 5th grade. Well, you're continuing to climb up the ladder of number sets, okay? And you find that this is the scariest one of all. You find that there's this set of numbers called rational. Now, don't run away, don't panic, because I'm going to try to make this a little bit more understandable. Rational numbers, to understand those and for it to be easy, you need to realize that we have to know what an integer is. Okay? So watch this. A rational number is a ratio. Now, ratio means you put something at the top of a fraction and something at the bottom. So a rational number is a ratio of two integers. Okay, now as long as the bottom's not 0. Okay, so let's put an integer at the top, 1. Let's put an integer at the bottom, -2. Guess what? -1/2 is an integer. Okay, now my little pen is a little bit marking a little bit too big, so let me change that. Okay, so let's think of another rational number. Is 1/3 a rational number? Yep, because look, an integer over an integer. How about 2/3? Yep, integer over an integer. That's rational. What about the number 5? The question is, can it be written as an integer over an integer? Well, we could just do this, right? 5/1. That's a rational number. Check. Okay? Now, here's what's really cool. What if I give you the number 0.3 repeating? Believe it or not, it's a rational number. And the way I know that is if I take this and I put it into my calculator, if I take this number and put it into my calculator, it becomes that number. So the number 1/3 as a decimal is 0.3 repeated. So repeating a decimal that's a repeating decimal is actually a rational number because it means the repeating part means that it came from a fraction. And a fraction consists of an integer over an integer, the way that we're talking about it, okay? All right. Now, let me throw some more rational numbers in here. 2.3. Now, why is 2.3 rational? Well, watch this. That's 2 and 3/10. Okay, well, 2 and 3/10 is the same as, remember, times that, add to that. That's 23/10. And guess what? An integer over an integer. Okay, so if you remember how to change a mixed number into an improper fraction. Okay, so 2.3 is, what about 5 and 2/3? Is that a rational number? Sure it is. 5 times 3 is 15, 16, 17, so that's the same as 17/3, and that's an integer over an integer. Okay, let's finish that. Irrational would be not rational, right? Now we have this weirdo, and I'm going to put this weirdo set over here that's kind of purple and kind of not even included in the original drawing, because irrational can't be written as an integer over an integer. Let me give you an example. Pi, right? Now, you say, well, it's 3.14. No, it's not. 3.14 is a rounded version, okay? It's a rounded version. So pi is actually not repeating, and it goes on forever. It's infinitely long. So another one would be like square root of 3. If you put that, pardon me, if you put that in the calculator, um, that's an irrational number. You can't write it as an integer over an integer without rounding. Okay. All right. Now, in both of these, and I'm going to put both of these together in one big, huge circle. This is the real number system. Real. Okay. Now, that's when you get into high school, right? When you get into high school, you talk about irrational, rational. I guess I skipped a little drawing that I should have given you, but so this is when you're in high school and you're driving your car and you're all big, right? You're all big and you know what you're doing. You think you know. We all did when we were in high school, right? And so this is real, right? When we find out about rational, irrational, and real, and all that when we're pretty much in our upper level math classes. Okay, so irrational is real, so is rational. Okay, so real would be this. Now, imaginary is over here. We're not going to get into that because this is just Algebra 1 video. But, okay, well, I hope this was helpful, and thanks for watching.